In this lecture, you will learn how to detect human faces. Specifically, we will write a script which will draw a rectangle to each of these faces in this picture. So the output will be an image, this image, but with those rectangles overlaid on top. To do this, you need two things. One is an image file which has some humans inside with faces which the script could detect, and also you need this har cascade file, which is an XML format. So you can download these two files from the lecture resources if you don't have them. A har cascade file is basically a set of instructions of how faces, human faces, look like. So Python will use this blueprint, this face blueprint, and it will use it to search for faces in an image. So let's write this script. We need OpenCV, so CV2. So the first thing we might want to do is load an image with cv2.im read humans.jpg, and let's load it in color. Then next, what we want to load is this XML file. So to do that, you could say something like face cascade. So it's called a cascade, hard cascade, and that is equal to cv2.cascade classifier, which gets as input the path to the XML file. So we have an image, we have a face cascade. What can we do with these two is detect faces using face cascade dot detect multi-scale, which means that you want to detect faces in different scales. So you could have a small face here, you have a big face here, depending on the depth of the photo, and you want to detect everything from that image object which we have in here. So image. Now it's good to have two other arguments here. The first one after the image is the scale factor, which usually it's good to have something like 105 or 11. And then the next factor is the minimum neighbors. So what is the scale factor and what is minimum neighbors? Well, what happens when Python detects faces is that each image has pixels. So the first pixel, the second, the third, and so on. And basically the program will go through each pixel. But some faces could be bigger, as I said, and some faces could be smaller. And so the detection depends on the scale of the image. So if the algorithm is looking at a certain scale, so at certain zoom, so to say, and it has in mind how a face looks like in that zoom, it could not find one because maybe the face in that level of zooming is bigger or smaller. Therefore, the algorithm has to check the image multiple times at different scales. So with this number here, basically you are saying how much to increase the scale between different scale checks, or the zoom. Let's say you want to start with a zoom of X, and the algorithm will check for faces there, and then it will zoom in with a factor of 1.1, so X times 1.1, and so on. So basically we have a pyramid of the same images but in different scales. And then we have 4. Now 4 is the minimum neighbors, which means there are interpolations between pixels. So if Python is checking this pixel, for example, it will also consider the neighboring pixels around it. So with 4 we're telling Python to consider 4 pixels around, and not, for example, more pixels, which would be like here and maybe here and so on relative to that pixel. So that's more or less, these are the popular numbers to use that have been tested to work well. but you can try with different numbers and see the results. Now, what is faces? Let's print it out and see what we have this far. So that is the faces variable. It's a list of lists. So one list here, another here, and so on. So basically a NumPy array, a 2D NumPy array. And this contains the coordinates of the rectangles which has faces inside. So basically we have 1, 2, 3, 4, 22 faces in total, which makes sense because there's a lot of people in this photo. So 22 faces, and for example, these are the coordinates, the pixel coordinates in the image of the rectangle to be drawn around a face, around the first face, and then another face, and so on. What we could do now is to iterate through that NumPy array using a tuple. So x, y, width, and height. What are these in faces? Right. So the tuple here, this tuple will get each of these lists. So basically x will be replaced with 901 in the first iteration, y will be replaced to 185, w with 60, and h with 60, and so on. So if we had an image like this, and then we would have 901, 185, that would mean something like the 901th column, which would be somewhere here, right? And the 185th row, which is somewhere here. So this one here, this point here, would be the start of the rectangle. And then we would go 60 pixels to the right and 60 down. So we would have something like a square, right? 60 here, 60 there. That would be a rectangle. And inside here, it's supposed to be a face. So that's the idea. We are capturing those numbers from each of these lists. And for each number, we will draw a rectangle using the cv2.rectangle method, which gets the image object as first input. So image, this one in here, we will draw those rectangles in that image. And then as second argument, it will get the coordinates of the start of the rectangle, which is x, y, as I explained you, the corner. And then you have x plus w and y plus height, so h. So what are these? Well, that is the coordinate of the first corner of the rectangle, that one. And then we say x plus width, which takes us somewhere here, and then y plus h, so it takes us at this point here. So basically we are drawing a rectangle using these 2 points as points to define that rectangle. That's what this rectangle method expects. The 2 corners, the coordinates of those 2 corners. Right. It also gets 2 more arguments. One is the color. If you want to have the rectangles white, you want to give 255 red and 255 green and 255 blue, and then the width, perhaps 4, so the width of the rectangle sides. And then once you write all the rectangles, so all these rectangles in the image, then you want to say cv2.imWrite and write that image. Actually, first you need to specify the name of the file of the new image. So let's say human faces.jpg and image, our image file object, which now has the rectangles inside. So it's one single image, and run. And here is the generated image. Let's open it, and this is the output. So as far as I can see, it has done quite a good job. Even though this face here is blurred, the script still detected it and drew a rectangle around it. This one too, even though it's also sort of in a profile, it's not front face. This one was successful also, even though the person has glasses, and it can also detect people with hats. And sometimes the script also thinks that a fist is a face, as you see in here. So of course it's not 100% accurate, but it's still doing a great job, I think. This face here is also a half face, so the script couldn't detect it as a face. I mean, that could be good, but it could also be a bad thing for certain scenarios where you don't want to detect half faces. So that's the reality. I hope you enjoyed this, and I'll talk to you later.